I would like to give the floor to Dr. Jan Šedivý, who will give the keynote on natural language processing. Jan Šedivý is the winner, his team is the winner of the chatbot competition, so he is competent person.
Hopefully.
To talk about this topic.
Okay.
It's your turn.
Welcome everybody. It's great to have the honor as well as privilege to talk to you and celebrating the anniversary of 10 years of CIIRC. I was one of the 13 people standing in front of the garage when we actually founded the institute, and it came to me as a surprise that it's already 10 years. During these 10 years, we've made a lot of progress. And I'll be today talking about one of the groups. It's an NLP group, and it's made up from many different students joined us on our way, as well as some of the scientists here from CIIRC. And as well as Holger, I will start in the history and will remember some of the key figures from the field of NLP who are from the Czech Republic and who helped us to get where we are today with the #1 language model, which is today the very, very well medialized and very well known GPT-3. And I am sure that many of you are using it, and many of you are surprised how well it works and how far we have gotten. So first of all, let me just tell you or repeat or refresh what the language model actually is. Here is a simple sentence: the sky is, and most of you would say that the following word is blue. It certainly can be also dark, or it certainly can be orange, or some other words may follow, but the probability of other than blue, it's much lower. And language model is basically a mathematical model, or it can be very, very simple frequent statistics, which is telling us what is the probability of the next word. And based on this idea, are trained or are put together most of the language models today. The idea actually originated in 1950, and it was brought to attention by Claude Shannon, and this was the time of Turing and Nyquist and many other important people who started the theory of information and brought the entropy and perplexity and other figures we use till today. And even that time, Shannon as well as Turing were warning the media people that the discovery or the description of information and the capability of working with information is not solving all the problems of the world. We are today in a very similar situation where the GPT is so much admired, and many people are giving it that much importance and claiming that most of the things are solved, but by far not. We are opening another page, which is follow-up what Claude Shannon actually started. So first of all, let me mention Fred Jelinek, who is our compatriot and who left to the US during the Second World War, and then he worked or he finished his university studies, and it was during the time where the information theory was brought up, and this gave him a good idea, or this gave him some impulse how to go after speech recognition. Speech recognition is obviously one of the biggest problems because, as has been already mentioned by Holger, the natural language is the most natural way to talk to machines or to talk to each other, and saying few words is much faster than to write regular expressions or SQL queries. takes much more time than saying something by words. And so that was the basic motivation of Fred, and this is where he devoted like 20 years to solving this problem in IBM, where he was leading the speech recognition group. And one of the major algorithms he actually introduced to be used in speech recognition were language models. The language models were obviously something what extended the Shannon game, where Shannon game was predicting the next character in an English word, but Fred was suggested to predict the next word as it was in the sentence, the sky is blue. And that time we had very, very few computational resources, so the language model were called n-gram models. And these were simple frequency statistics, and we used bigrams or trigrams, which means we knew 2 words. So from the 2 words, we had statistics telling us what is the most probable or very likely next word. And it was easy to compute it, and for many, many years, this was the only way how to do it. And obviously, as there is in the blue rectangle, at that time, we have been already running speech recognition, but on very, very weak machines like Windows 95, 420 megabytes, not gigabytes, megabytes of disk and 4 megabytes of RAM. And in that space, we had to work like with 30,000 30-dimensional Gaussians and many, many other problems. And we did it. We had small computers, we had very few resources, but we had smart algorithms. So this was Fred, and there are some other important points, but I'll skip that for the moment. And I will mention some of the tasks which actually evolved from language modeling, where language models became the key or the decising algorithm which brought us or which enabled us to work on things like translation, which has been mentioned, and speech recognition, but also many other things which are very important in many industries today, like text classification, where we can find out what is the text about, text summarization, which I wished I had for scientific articles, to find one paragraph where there is something new and skip all the front and back talking, which is taking a lot of time but bringing no information. Then named entity recognition, which is very important for information extraction. These are the situations where we would like to go, for example, for news articles and find out who left which company, who became the new CEO, etc. So these are the business information where the text entity or named entity is used. Natural language generation, that's something what I'll be talking very quickly about. And then I'd like to mention that AI and especially NLP was used from the very beginning of companies such as Google, Baidu, Seznam, and all those guys who do full text or who do search on the internet. And at the beginning, it was just expanding the query with synonyms or rewriting the query to take into account possible other questions. But later on, it turned to being able to find very quickly what is the intent of the user, because if the user writes something like plastic windows, does he want to buy them or does he want to fix them and so on, then algorithms for relevancy, which means like how to sort. It's not only PageRank these days, there are many, many other features which are used. Google calls that signals, so they have like over 200 different signals to find out what is relevant. So let's go further. And I'd like to stop by Tomáš Mikolov. I don't see him, but he is now member of CIIRC. And I am very happy he's sitting next to me, because this is one of the persons I enjoy to talk to, because he very quickly understands what I am talking about, and I understand him. So that's a very, very fortunate situation, because Tomáš Mikolov is one of the key persons on the way of generating or training language models. It happened end of 2010 or before 2010. He met Fred Jelinek, who was at GHU. He was a professor there, and he was every year making summer schools, and at that time Tomáš was visiting. At that time Fred didn't believe that what he is suggesting works, and what Tomáš suggested is to use recurrent neural networks, which were known from late 90s, and that time they were not usable, or they were not practically usable because of the limits of the data and because of the computational limits. And Tomáš was actually the first person who managed to train these recurrent networks, and he was the first who actually put together the backpropagation algorithm, which enabled us to use these recurrent networks for modeling language. The benefit was enormous. Up to the 2010, we had the context of the words from which we were able to predict the next word, like 3, maximum 4 different words. But with the bring up of RNNs, we extended the buffer, or we extended the context to approximately 20 words. So you can imagine that if you know 20 words or sentence of 20 words, then the likelihood that the generated words will go out of topic or will start to talk about something we didn't want is much lower than if we do it with 3 words. Very, very quickly after his discovery, which is like 2013, there were some other few algorithms like LSTM neural networks, and they extended the context to about 60 words, but obviously again, we have been facing the problem of enormous computational requirements and large data and many other difficulties. Here, I'd like to mention what happened to me after I left the industry and came to CIIRC, where I had the opportunity to get back to research and to talk to students and to talk to other researchers and extend what I have been doing before. And it was like 2013, 2014, when we started to work on internet applications with the emphasis on NLP and with the emphasis on speech recognition, text-to-speech. And that time we started with very simple question answering, which we did with embeddings. Again, we used fast text, which is another of Tomáš Mikolov's inventions, and it went quite well. And then suddenly in 2016, thanks to Amazon, Amazon came up with a competition Alexa Prize and challenged the academic teams to create a chatbot which would nicely talk with users about social topics. And since we knew few things from NLP, we decided to go for it. And we were selected. And most important thing that time was we got like 250K subsidy for students, which was far enough for scholarships. And we started to work on it, and we started to create bot called Alquist. And we didn't expect that, but in the first run of this competition, between 200 academic teams, we placed on the second place, which was fantastic. And then we continued, and we were twice in a row second. And finally, last year, we won the competition, and we always joke that Stanford was only second. So this was the journey we were following with our students in the field of chatbots. What happened? Here is some small demo.
Open Alquist.
Hi, this is an Alexa Prize social bot. Is it you again, Andrew?
Yeah, it's me.
What a faithful chatmate you are. How are you today?
I'm pretty good, thank you.
Hip hip hooray! I'm happy for you, Andrew.
Let's chat about movies.
I was wondering, who is your most favorite actor?
I like John Travolta.
John Travolta, really? What an interesting choice. Can you tell me, why do you like this actor that much?
I like the movies that he's in.
Oh, so that's why John Travolta is your favorite. I had never thought of John Travolta when I asked you. Now that I think about that, I think I like this actor too. However, my favorite one is Harrison Ford, because I love Star Wars. Well, I guess you are a good cook, right?
No, I'm not.
And is this something you think about yourself, or is it scientifically proven?
Well, I think it could be proven scientifically very easily. I'm not a good cook.
So this was a snapshot of how the bot works sometimes in 2018, 2019. These days we are much further ahead, and I will explain some of the technologies we use, but I also will mention one of the research results which now is being used also in industrial applications. And this is a simple system. It is typically called an application helping people to go over maintenance, setup, or fixing stuff, and it's called standard operating procedure. And we made a smart operation procedure where we can extract the steps the worker or the maintainer needs to do from a manual, and we can create out of it step-by-step recommendation of fixing certain equipment. What more, the system is also equipped with a semantic search. So if the user has some question, we have a manual for the particular piece of equipment, and a user may ask, and if the answer is somewhere in the manual, we definitely find it and we can answer. It can be run on mobile devices, and it uses speech recognition as well as text-to-speech to leave the hands free and to operate very easily. Here is the final cut, so to speak, for today, and it's the GPT language model, which was very ironically started by people from Google in 2017. There is this famous paper called "Attention is All You Need," and from that on, we date the history of these amazing machines. It started with GPT, we call it today GPT-1, then GPT-2, and we have for quite some time were using the GPT-2 in our systems, and then at end of 21, the GPT-3 came, and then later on the other incarnations of the system. Certainly, we have to be aware of the background which was enabling to do this research and to get it as far as it is today. And the very important or the key things were the investments. Also, Elon Musk was investing, but in 2019, Microsoft put $1 billion to OpenAI, and this January another $10 billion, and behind the scenes there is definitely war between Microsoft and Google, because Google has BART, but thanks to EU regulations, BART is not accessible to Europe. It's worldwide enabled 3 weeks ago, but without EU. And this the big investments of 10 billion are particularly geared by the fact that at the beginning of the year, the Chrome browser from Google had 82% market share, and Bing had a very negligible market share. So the GPT-3 is now through Microsoft available only through Bing. It's hard to get it to Chrome. So that's a fight between these two companies to get a majority on the market. And obviously there are many other points which are addressed by this war, and we'll see how it will end up. Clearly, Google is much more cautious, and Google is stepping in much smaller steps to get to the field of this AI because of the all risks which are associated with this technology. So here are the few points how it went in the history, and I'd like to mention that the GPT-3 has 175 billion of parameters, and it was trained on 410 billion of words. So these are really amazing numbers, and I will follow to the next page where there are some funding issues or the cost associated with creating models of this type. So all of this is running on NVIDIA cards. NVIDIA is the major company providing graphical cards, and the graphical cards are the key hardware to actually run such a massive number of computations. Typically, the cloud centers are equipped with boxes of NVIDIA GPT and GPU, and these are these days usually put together in 8 pieces. These 8 graphic cards comes with 320 gigs of memory, but the GPT 3.5 requires 800 gigs of memory. So this has to be run on more than these 8 CPUs. But to give you the perspective of how much it is, these 8 graphical cards cost $200,000 US, and there are hundreds or thousands of them in one cloud center. One of these boxes takes 28 kilowatts, which is enormous demand of energy. Therefore, all these cloud centers are built close to water power stations to get the cheapest possible energy. And the estimates are that we are closing to 2% of the worldwide produced energy is spent by cloud centers, which is not definitely a very positive message from the point of view of the environment. And to conclude this page, it is definitely not easy for academic teams to compete in this field, but there are still many opportunities because we are we opened new page, and there is still a lot of work we have to do, and I will talk about it on the next pages. So here are some points we follow while developing, or we are challenged while developing our ArcVist 5, which is the latest version. We have today about 6 students, PhD as well as MSc students who are coming to CIIRC and using our facilities as well as using our cloud center, which is really essential for building our models. And as you can see here, the challenge has a little bit changed because Amazon stepped in and asked us to create the chatbots also for Echo line of devices with screens, which means that we have to do, or we have to work with graphics, and that brought us to the field of animation, like Unreal Engine, which is used in games, where we can animate photorealistic avatars and let the avatars speak and listen. So this is what we are currently stepping in and do the first steps, and we also have some few new applications. We don't use ChatGPT because the rules, and I think it is very wise, don't allow to access out of AWS. Everything has to be processed inside AWS, and there we cannot run GPT. So we are using smaller language models. We use models on the edge of 10 billions of parameters, and that's where the language models are becoming slightly different than the previous sort of language models. They are so-called instruction aligned, and these models don't need to be terribly fine-tuned. They usually absorbed all the required language and have to be controlled slightly differently, and I will show soon how. Yes, that's probably all what I would mention here, even though many other points which are important. Here is one of the pictures which shows the graphics we use now on. The microphone is giving me a headache. But this is one of the pictures we have on Echo device, and we use some karaoke effect. So when the system speaks, it actually highlights the text which is playing back. On this slide, I'd like to give you an example of how the language models are used for creating a dialogue, because the way how we do it, and it's called prompt engineering, is very easy, and it's the same as the GPT is controlled today. And it's something what you can really try by yourself and write, for example, a book using GPT 3.5, the ChatGPT, or GPT-4. And it's called, as you can see in this block, this kind of prompt is advising the system or giving the system an instruction to translate, and it shows example of the translation. And on the last line, there is something called cheese, and then the arrow, and the system is instructed this way to follow up with the expression in Czech. So that's the very simple way. Here is something, or this is exactly what we have in our bot today. So this is an instruction to ask the bot, or to ask the language model to behave as a chatbot and to be sarcastic and witty. And so as to give the bot an example of what it is, sarcastic and witty, we give this very short example of a conversation. And again, the last line where there is the social bot is left empty and the system happily includes something. Yes, there are problems that the answer may not be politically correct and that the system may invent something we cannot play back. So we have many different systems built in to protect users from any profanities, etc. I just would like to mention what had happened once in Amazon, just before Christmas, they invited kids of their employees to the company, and they used one of the bots and show the kids how they can converse. And what had happened, suddenly our bot said something like, "Santa is dead." And that was definitely a big disaster from the point of view of Amazon, but it's very difficult to protect the bot from generating sentences like this, because the bot would have to have some street smart. And there is nothing like that. It's just a parrot. It repeats what it heard. And we feed it with Common Crawl, which is a snapshot of internet on AWS, and it has it's tremendously large, but there is everything. There are all the political incorrectness, all the biases, and there is no way how to manually filter it. So we do our best, and not only us, but everybody, to come up with new ways how to filter out what may potentially hurt many of our users. So here, this is just a definitory or definition about what we call parametric knowledge, and that's something like the sky is blue. This is what the bot has learned, and the language model has learned, and that's by default there. But we also need knowledge about, for example, what were the results of ice hockey last night. And that's what the language model doesn't know, because the language model was trained sometimes end of 21. And to do the updates, we have to do another tricks. And this is shown on this slide, where we have another prompt. And the prompt contains something what we call context. And the context is a text where there is possibly the information the user asked, or the information we want to mediate the user. So that's the way how we get the latest, or how we get the information which is typical for particular topic. The current research is focusing on finding algorithms which are less demanding from the point of view of memory and CPU. We are working on knowledge extraction, user's opinion estimation, where we believe that the language models have a lot of information which has never been used yet, or people haven't thought about it yet, and these are the new arrays where we would like to follow. Here are challenges. I think that Holger has very well pointed out the many biases and inaccuracy and many other problems we are actually facing while developing artificial intelligence as a whole, and NLP or language model especially. I also would like to repeat at this point that one of the serious problems is the energy consumption. Then the other problem we are solving is updating to create continuous updates. Then multimodal, which combines a picture, which combines voice. We have the first research examples of generating not only pictures, but generating video from text. So that's the direction we are moving to. It is very important, and it definitely will happen. Accessibility and usability is another very, very important and today definitely overlooked area, because there is a Copilot, which is a system for programmers on GitHub, where programmers, while programming, are supposed to write first comments and then to follow with code. So in Copilot, they write first comments, and Copilot generates the code, and they can pick from 3 different versions, which they include to their code. Yes, it is dangerous for companies like Apple and others who banned to use their programmers to use this system, because the one who is running this system may easily, from the conversation from different domains, figure out what kind of programs they work on. And I'd like to close the presentation with saying thank you to all the faculties and the leadership of CIIRC, and to students, because it's a great home for all of us to continue working on this extremely interesting, and I also believe extremely important research problems. Here are some points how we do it, how we work with students, how we would like to engage them in working with our industry partners, etc. So thank you very much. That's it.
Thank you very much, Jan. And now there are no questions on Slido, so questions in the room. Everything is clear, but I still do hope so.
It was so obvious that there are no questions.
There are questions.
Oh, okay.
Okay.
So, Jan, thank you so much. I mean, for me personally, this was a super insightful talk. In fact, you should have gone first. That would have been more effective. So let me ask you this. I like the fact very much that you put an emphasis on the importance of large-scale computing resources to really do cutting-edge research in this area, right? So, do you think in the medium and long term there is a problem if researchers like you who do this at public institutions, paid by the public, responsible to the public rather than to shareholders, have difficulties having access to these resources? Do you think that that's holding you back? Or let me ask differently, do you think if a large-scale public compute infrastructure were available, that would enhance your ability to do the wonderful research you're doing?
Well, today we have access, we pay this $20 per month, so we have access to OpenAI. And what I believe is that certainly these days companies such as Apple and so on, where the programmers do not have the access, these companies will soon have their on-premise devices or language models of similar capability. So they will do everything behind the firewall. So that's definitely the expected progress in this field. So, and what you are saying about the companies or the big moguls and the public, that's something which is hard to predict. There were many lawsuits in the end of 19th between many different content providers and Google, and most of the lawsuits ended up in nowhere because the public demanded so much the quality, the so good search, that the public pressure actually alleviate all these problems. And I believe that something very similar will happen with NLP, because the students suddenly bringing up their thesis have fantastic English. So when I read it, I definitely know where it comes from, and that's a benefit. So I strongly believe that we will find our ways how to use it. We are at the beginning, so we still have only few.
If you allow me to follow up, I share that feeling, but I also have a big worry, and the big worry is that, you know, if there's wonderful companies like Amazon and so on who make this available, that's great, right? But if anything ever happens so that, for instance, in Europe, we lose access to these computing resources, just like basically overnight we lost access to the Russian natural gas on which we had become dependent, don't you think this would be a massive problem? I mean, in other words, is it safe, is it responsible to bet on a small set of companies alone to provide access to key technology that will drive soon large parts of our economy and society indeed? To me, that sounds very problematic.
Yes, you are aiming at the right direction. Clearly, Europe has to make up its mind and come up with some funding or come up with establishing communication between scientific teams, because today most of the scientific teams, because of being so much dwelled in their problems, they don't communicate enough. So if we all get together in Europe and start to work on something similar like OpenAI, and we know much more than when they started, so we should do it much faster. That is something what we definitely should do, not only because of to be lost or to be disconnected, but because of learning it and because of reusing it for our own benefits. Because as you said, there are, the problem of Apple or not letting the programmers to use it is because they would do nasty things. They would release what is secret information easily without thinking. They would act mechanically, and that's the difficulty. So if we do it in Europe and we virtually provide it, for example, for companies so as they keep their privacy, that's the way how we should act.
Excellent, thank you.
Okay, I think your question, Holger, was good starting point for the first panel discussion in the afternoon, because we will talk about trends of AI research and how to build AI ecosystem in Europe, and this is substantial part of the discussion. So we are a little bit behind the schedule. So Jan, thank you very much for the presentation.